Hello students, welcome to Rasaayana. In the continuation of our last video regarding Vsepr question which was asked in 2024 advanced, the question was related to different xenon compounds. We have to match with the corresponding geometries and lone pairs. In the last class we have seen what are the different types of geometries and the lone pairs. For a given electronic geometry, what are the various derived geometries, or we also call them as molecular geometries or shapes of the molecules. So just let us revise quickly. Suppose if I take steric number 2. For 2 we have sigma bonds as well as lone pairs. We are not going to consider any pi bonds. So for steric number 2 we have 2-0 combination and 1-1 combination. This is one combination. For steric number 3 we have 3-0 combination, 2-1 combination and 1-1 combination. This should be 1 plus 2. For steric number 4 we have 4-0 combination, 3-1 combination, 2-2. We can also take 1-3. When steric number is 2, the geometry will be linear. This should also be linear. When steric number is 3-0 combination, always just remember 3-0 combination, it should be trigonal planar. 2-1 combination, angular or bent. 1-2 combination, linear. Then for steric number 4, sp3 hybridization, 4-0 combination, tetrahedra. 3-1 combination, trigonal pyramidal. 2-2 combination, angular or bent. 1-3 combination, linear. These are the molecular shapes or the molecular geometries for a given electronic geometry. Electronic geometry is fixed for a given steric number. This is for 2, 3 and 4. Let us also check for 5 and 6. 5 is more important for the examination point of view. For steric number 5 we can have 5-0 combination, 4-1 combination, 3-2 combination and 2-3 combination. And for 6 we have 6-0, 5-1, 4-2. We can stop here. 3-3 can also be taken, but it will be like a hypothetical molecule. We are not going to discuss any hypothetical molecules here. For 5-0 the geometry will be TBP. For 4 plus 1 combination it is seesaw. For 3 plus 2 combination it is T-shape. And 2 plus 3 combination it is linear. You have to remember them at your fingertips. 4 plus 1, 3 plus 2, 2 plus 3 combinations. No combination will be repeated. Okay, blindly remember. 6 plus 0, octahedra. 5 plus 1, square pyramid. 4 plus 2, square planar. These are the molecular shapes. So this is what we have done in our last class. Okay. Coming to the method to derive the geometries, the method that we are going to apply is a simple logical method. The first step, we should have an idea about valence electrons of the central atom. So you should go through to which group does it belong to. Based on that, you have to derive the valence electrons of the central atom. Second one, valency or combining capacity of the bonded atom. Combining capacity of the bonded atom. Third one, we have to assign the steric number, and then from the steric number we have hybridization and a corresponding electronic geometry and molecular geometry. How does it work? Let us take an example from the in the last class question. The molecules that were given were XeF2. This is one molecule. XeF2, xenon has 8 valence electrons. Simply write 8 valence electrons. There are 2 fluorines. Each fluorine is monovalent, so it will form only single bond. This is one fluorine, this is second fluorine. whatever electrons that are remaining, they convert into lone pairs. Every lone pair is considered as a domain. Every bond is considered as a domain. Every bond means every sigma bond should be considered as a domain. Let it be a single bond or a multiple bond. So here this is one domain, second domain, third, fourth and fifth. Here I am getting steric number as 5. For 5 it is sp3d. Electronic geometry is, for sp3d electronic geometry is TBP. But what is the combination here? 5 is existing as 2 plus 3. 2 plus 3 lone pairs. Here we have 3 lone pairs. Okay. So 2 plus 3. Geometry is TBP. 3 lone pairs. Now you can match it. From the last video question you can just go through and you can match it. 2 plus 3 combination. It is TBP. What is the structure for 2 plus 3 combination? For 2 plus 3, molecular shape will be linear. But in the exam they have asked electronic geometry. So it was TBP with 3 lone pairs. Completed first one. Let us move for the second one. XeF4. Take xenon. 8 valence electrons. There are no charges. If at all there are any positive charges, you have to subtract an electron. If there are negative charges, you have to add an electron. Later we have 4 fluorines. Each fluorine is monovalent, so it will form single bond. It is taking 4 domains. The remaining 4 electrons are converted into 2 lone pairs. So we have 1, 2, 3, 4, 5, 6. Steric number is 6. 6 is existing as 4 plus 2. 2 lone pairs. For 6, we know it is octahedra. Steric number 6, octahedra. Octahedra with 2 lone pairs. Octahedra with 2 lone pairs. So molecular shape will become square planar. But in the exam they have asked only trigonal. They have asked only electronic geometry. Trigonal, bipyramidal, octahedra, such electronic geometries only. Third molecule they have given was XeO3. Again put xenon, 8 valence electrons. I'll also tell you the shortcut. This is a logical method to arrive at the geometries and lone pairs. I'll also give you a shortcut method. In that shortcut method directly you will get the hybridization. So here we have oxygen which is divalent. So 2 bonds, 2 bonds and 2 bonds. This is leaving a pair of electron. Every multiple bond is considered as a domain. So now this is one domain, second domain, third domain. This is a fourth domain. Steric number or number of domains are 4. 4 is existing as 3 plus 1. But one steric number is 4 means electronic geometry will be tetrahedra. Tetrahedra with 1 lone pair of electron. Molecular geometry or shape will be trigonal pyramidal. This is an additional point. In the exam it was related only with this electronic geometry, tetrahedra. So TBP with 3 lone pairs of electrons, octahedra with 2 lone pairs of electrons, tetrahedra with 1 lone pair of electron. And one more last molecule that they have given was XeO3F2. Put 8 valence electrons for xenon, 3 oxygens. Each oxygen is a divalent, so put double bonds. Each fluorine is a monovalent. Every multiple bond is a domain. 1, 2, 3, 4, 5. So steric numbers or domain is 5. 5 is existing as 5 plus 0. 0 lone pairs. Once if it is 5, the geometry is TBP. Electronic geometry as well as molecular geometry is also TBP with no lone pair of electrons. Okay. So you can match in the equation. The option will be B, second option. Second option is found to be the correct answer. Just let me draw the structures for you. The first one was XeF2. This is XeF2. Second one is XeF4. Third one is XeO3. Fourth one is XeO3F2. Here there is a lone pair. Here there is a lone pair. And one more lone pair here. Here there is a lone pair. Lone pair. And a lone pair. So these are the structures of XeF2, XeF4, XeO3 and XeO3F2. All this is a detailed methodology to get the answer. Now a shortcut. Just to get the steric number, direct shortcut. What is the shortcut? The shortcut is, this is to get the steric number and hybridization. Shortcut to get steric number and hybridization. The shortcut is steric number equals half of number of valence electrons of the central atom taken as V plus number of monovalent atoms, which are the surrounding atoms or the bonded atoms. So M represents the number of monovalent bonded atoms, minus C, if at all there are any cationic charges, all those cationic charges must be subtracted, plus A, any anionic charges must be added. This is a shortcut formula. Let us apply it for XeF2. For XeF2, what is the steric number? This is half of. Central atom is xenon, 8 valence electrons. How many monovalent? Fluorine is monovalent, oxygen is divalent. So fluorine is monovalent, we have 2. Minus 0 plus 0. No cationic or anionic charges. So this is half of 10, which is 5. For 5, we know that it is sp3d. So this is giving you the number of, it is giving you the steric number and the hybridization. But to get the detailed structure, molecular shape, how many lone pairs of electrons are present, the previous method, that will be a better method. Let me take XeF4. Steric number 1 by 2, 8. There are 4 monovalent atoms, no cationic charges and no anionic charges. So this becomes half of 12, 6, sp3d2 and octahedra. You are getting the electronic geometry here. XeO3 1 by 2. All oxygens are divalent, so no monovalent, make it 0. This is anyway 0 and 0. So it is half of 8. 4 is tetrahedra. And the last one was XeO3F2. O3 divalent, fluorine monovalent, 2 monovalent, so 8 plus 2. No cationic charges and no anionic charges, so it is half of 10, which is 5. For 5 it is TBP, trigonal bipyramidal. This is a shortcut method to get the steric number as well as the electronic geometry. But to get the molecular shape, the number of lone pairs, the previous method is a perfect method to understand. This is about our 2024 advanced question. Thank you.